Good day, welcome to another video where we're setting a new chapter on functions. Basically, we're doing linear functions. So here's a question for the video. If f of x is 2x plus 3, what then is g of x, which is equals to f of x plus 3? Let's get started with the video. Okay, so remember in grade 11 you had y is equals to mx plus c, of which your y will be what? Will be your y values, right? And then x will be your x values, and then your m will be what? Will be your gradient, right? And then c will be what you call the constant or y intercept, right? Of which from that we knew that y was what? Dependent, right? Dependent on what? On x values. On x values. And then x was what? Was independent, right? And then we also knew that gradient was basically what you'd call slope slash inclination, right? Of which that will be your y2 minus y1 over x2 minus x1, right? And then the constant of y intercept will basically be what? It will basically give us the y intercept, which will be 0 is to c, of which 0 was the x intercept of the x value of the x intercept, and then c was the y value of the y intercept, right? And then our gradient, we also knew what? We knew that when it was positive, we were rising, right, from left to right. And then when it was negative, we were going down from left to right, the very same way we write in English. So that is your reference, right, to left to right. Okay, and then the most simple graph that we had was what? It was y being equals to x, of which from this we knew that our gradient was 1 and then our constant, our y-intercept was 0, right? And then this basically meant what? It meant that for every change in x, y changed by an equivalent value, right? Equivalent value, okay? Graphically, this will be something like 1 and 1 changing same value, and then -1 and -1, right? Of which it was important to label our axis, the y and x-axis. Okay, and then we'd also have something like y is equals to 2x plus 4, of which from this one, it basically meant what? For every change in x, y doubled, right? Okay, the gradient is 2 in this case, and then our constant was 4. Okay, and this meant that such that if x is equals to 2, therefore y will be what? Y will be equals to 4. Okay, and then one thing to note as well was we'd have many forms in equation at which they'd ask us about the general equation, of which we know standard it was mx plus c, but it also sometimes have something like y is equals to mx plus k, right? So basically c is any value, can even have b there or anything, didn't matter what you had. And then one thing that we also knew about a gradient, I'm just gonna write it down for you here. Okay, one thing we knew about a gradient was that, okay, here's our standard graph, right? Which is the graph of what? Let me not forget writing the axis. It will be y is equals to x. And then what we therefore have was what? It will be that as the gradient increased, your graph will get closer and closer to the x-axis, right? So this here will be y is equals to 2x. You see that it's gotten closer to the y-axis, right? And then for example, our graph of y is equals to, okay, let me write it here. Y is equals to 3x will be even much more closer to the what? To the y-axis, right? And here for y is equals to 3x, if x is equals to 1, y will be equals to 3. Okay. And then okay, continuing, we also learned about intercepts, right? Of which our x-intercept, we knew that we had to let y is equals to 0, and then for our y-intercept, we knew that we had to let x be equal to 0, of which here would end up basically with 0 is to c, the constant, as I highlighted above, right? Okay, and then we also had perpendicular graphs. Okay, we had perpendicular graphs, of which for perpendicular graphs, we knew that the gradient of the first graph and the gradient of the second graph had to give us -1, such that if here your gradient was 2, you knew that the gradient of the second graph would have to be -half for the two to have to be perpendicular, right? This in real terms is basically you having y equals to 2x plus maybe 3, and then you having y is equals to negative x plus 2, right? So those two graphs will be perpendicular. Okay, and then yeah, now we also had a way of naming our graphs, right? So instead of calling it y equals to 2x plus 3, we'd call it, for example, f of x, which will be equals to 2x plus 3. So this will read as in the graph of f for a certain value of x is basically equals to 2x plus 3, of which, for example, f of 1 will be equals to 2 1 plus 3, right, which will give us 5. So the graph of f at the value of x being equals to 1 is basically equals to what? 5. So basically meaning that when x is equals to 1, our y is equals to 5, right? Okay, and yeah, in that manner, f of -2 will be basically 2 minus 2 plus 3, which will give us -1, right? And yeah, this naming system made it easier for us to maybe have two graphs on the same axis and also maybe in equation. So you'd basically maybe have this graph being called the graph of f, and then maybe the one with a negative gradient being called the graph of g, right? Yeah, so that was a good way of simplifying labeling, of which when the video started, I asked the question, yeah, which I will be answering very soon. Okay, so for example, if we had f of x being equals to 2x plus 3, and then we're told that the graph of g of x was equals to f of x plus 3. This graph will basically mean what? It means that instead of x, now every time the x value changes, we add 3 on top, right? So this will basically be 2 and then x plus 3 plus 3, right? So instead of us having x here, we now have x plus 3. Every time x that is no longer x, but it also changes by 3 units as well, right? So this will be 2x plus 6 plus 3, which will give us 2x plus 9. So these graphically will be basically, let me just show you now. It's important to start by labeling our axis, right? And then so we know it will pass through 3, the first graph of f, right? So it will be something like this. This will be the graph of f. But then what you'd notice with the graph of g is what? It will actually pass through 9, right? As we can see from the new equation, it will pass through 9, of which what you notice as well is what? It actually moved to the left by how many units? It moved to the left by 3 units, right? And then how many units did it move by upwards? It moved upwards by 6. Okay, so every time the x values changes by 3, right? Of which what you also notice is what? Effectively what you notice is that y, instead of y changing by 3, changes by 6, right? Why does it change by 6? Remember, we have 2, and then multiply by the value that we change by, which is equals to 3. So this gives us 6, right? Of which if x had changed by 4, every time y will change by what? Basically by 8, right? So that's what it effectively means. Okay, and then we'd also have the cases where we'd have a parabola and then the linear graph, right? Of which sometimes they write a linear function as in x plus y is equals to 8. You'd note that you would have to make y the substitute formula, of which you'd have y being equals to negative x plus 8. Okay, and then also another case which we'd have would be maybe they ask us where is the graph of x plus y equals to 8, and maybe a parabola which will be equals to y is equals to x squared plus 2x minus 3, asking you where do these two graphs meet. So here basically you'd have to first make y the substitute formula, right, on this side plus 8, and then from there you know that your y values are the same. Therefore, you'd equate negative x plus 8 being equals to x squared plus 2x minus 3, and solve for your x values and see where they met and find their respective y values, right? I'm giving you that as an exercise for you to do. But anyways, as in closing, we'd also maybe have something like, let me write it on the right hand side. We'd also have something like maybe they say the graph of g of x is equals to f of 2x. So in that case, you'd basically, instead of substituting x, you'd therefore substitute 2x, right? Of which this will be therefore a graph of, I'll change this, it will become 2 and then 2x plus 3, right? Of which this will give you 4x plus 3. Okay, and then you can plot that and see how it changes. But basically here, instead of the gradient being 2, it will be much more steep, right? Okay, and then thank you for watching the video till the end. Kindly like, share, comment on what it is you'd like me to cover. However, in the following video I'll be doing parabolic graphs. Thank you.